हेलो एवरीवन, वेलकम टू गेट वाला। कैसे हैं सारे लोग? आवाज़ आ रही है मेरी? गुड इवनिंग। गुड इवनिंग अनिरुद्ध गोयल। गुड इवनिंग। आवाज़ आ रही है? ऑडियो में कोई प्रॉब्लम तो नहीं है? ऑडियो में कोई प्रॉब्लम तो नहीं है? आगे बढ़ें, आगे बढ़ें। चलिए चलिए थोड़ा सा आगे बढ़ते हैं और समझते हैं। लास्ट जो टॉपिक चल रहा था वो चल रहा था लॉजिकल ऑपरेटर। लास्ट जो टॉपिक चल रहा था वो चल रहा था लॉजिकल ऑपरेटर। ठीक है सर। सर मुझे एक बात बताइए, अगर मैं आपसे कहता हूं 12 और यहां पर कुछ भी लिखा हुआ है, व्हाट इज द रिजल्ट? व्हाट इज द रिजल्ट? व्हाट इज द रिजल्ट? यहां कुछ भी हो, व्हाट इज द रिजल्ट? यहां कुछ भी हो, व्हाट इज द रिजल्ट? सर डू वी नीड दिस? डू वी नीड सेकेंड ऑपरेंड? सर और ऑपरेटर ये कहता है एटलीस्ट वन ऑफ देम मस्ट बी ट्रू, एटलीस्ट वन ऑफ देम इज नॉन जीरो। तो आराम से समझते हैं, अगर फर्स्ट ऑपरेंड नॉन जीरो है, फर्स्ट ऑपरेंड नॉन जीरो है, देन क्या हम यहीं पर श्योर हो गए कि रिजल्ट 1 आएगा? एंड वी डू नॉट नीड सेकेंड ऑपरेंड? सोच समझ के बताइएगा। अगर फर्स्ट ऑपरेंड नॉन जीरो है, ओके सॉरी दिस इज वीकेंड बैच, सॉरी because the first operand is non-zero and we know that OR operator says if at least one of the operand is non-zero, my result would be 1. So if the first operand is non-zero, do I need the second operand to get the answer of logical OR operator? Sir, if the first operand is non-zero, I don't need the second operand. Why? Because even if the second operand is 0, the result is 1. If the second operand is not 0, the result is still 1. That means, sir, it does not really matter. It does not matter what is the second operand. The result is 1. It does not really matter that the result, it does not really matter that the second operand is non-zero or 0. The result is decided only by looking at the first operand. That is why if the situation is something like this, compiler will not evaluate the second operand. So try to understand, this is called as short circuit evaluation. This is called as short circuit evaluation. Sir, what is short circuit evaluation? If the first operand, if the first operand for logical OR operator, is non-zero or true, second operand will not be evaluated. Sir, sir, if the first operand is non-zero, why to check for second operand? I can answer only at looking by the first operand. Is it okay? So this is short circuit evaluation for logical OR. In case of any confusion, feel free to ask. In case of any confusion, feel free to ask. Did you get it? That means, sir, if I ask you something like this, hash include stdio.h void main int a is equal to printf Pankaj or printf Sharma. What is the answer? What is the output of this code? What is the output of this code? What is the output of this code? Sir, if you are asking for output, first of all, we know that the priority of logical OR is more as compared to assignment. That means first we need to evaluate this OR, the result of this OR. Now, printf Pankaj, the first operand is printf Pankaj. To get the value of printf, first it must execute. That is why Pankaj will be printed onto the screen, and because it printed 6 characters, the value for this printf becomes 6. So can I say something like this? A is equal to 6 or printf Sharma. Now, because the first operand is non-zero, sir, the answer for A is always 1. Because the first operand is non-zero, the result that goes inside A is 1, and this will never gets evaluated. So the value that goes inside A is not 6, it is 1, because the result of logical OR operator is either 0 or 1. Now we are printing the value of A, that is why we got a 1 over here. So the result is Pankaj 1. Don't say the result is 1. The result is Pankaj 1. The output of this code is Pankaj also. See, printf must execute, na? So the result is Pankaj 6. Is that okay to everyone? Is that okay to everyone? Okay. On a similar note, if I ask you, try to understand. 0 and anything. Sir, the result, what is the result? What is the result? Sir, the result is 0. So do we need this? Do we need this? Do we need to evaluate second operand? I hope the answer is no. I hope the answer is Manas, we will talk about it later. /n or /t. No, sir, because even if you put a non-zero value, the result is 0, or 0 and 0, the result is 0. So does it really matters? No, sir. And that is why here also we have a short circuit evaluation. That means in case of logical AND, what is short circuit evaluation? If the first operand is 0, if the first operand is 0, then second operand will not be evaluated. Will not evaluate. Is that okay? That is called as short circuit evaluation of logical AND. Okay. That means now if I ask you something like this, tell me the output. Tell me the output. Sir, 0. Sir, this printf is not printing anything. This printf is not printing anything. That is why, if this is the screen, this printf will not print anything and the value becomes 0. That is why, can I write something like this? A is nothing but 0 and printf Pankaj. Of course, sir. And because of short circuit evaluation, this will not evaluated. And 0 and something is 0. That is why the value that goes inside A is 0. So the output of this is 0. I hope things are clear now. So tell me, if I write int A is equal to Tell me the result. Is there still sound related issues? That buzzing sound or that unwanted sound is still there, or everything is okay? Is that buzzing sound is still there, or everything is okay? No buzzing sound, na? Everything is okay? Now, tell me the priority. If I talk about the priority of not is more or and? Sir, because not is a unary operator, the priority of not is more as compared to and. That means first the result of this would be evaluated. But in order to evaluate not operator, we need to execute printf. Okay, sir. So try to understand. This printf will print Pankaj, but after printing its value becomes 6. Now we have not of 6 and printf Sharma. Because the priority or precedence of not is more, first this will be evaluated. Okay, sir. So what is not of 6? Not of 6 is 0. Now 0 ending with anything is 0. This will never gets evaluated. Is that okay? And the result that goes inside A is 0. So what is the result? The output of this code is Pankaj 0. Is that okay? Now, biggest twist in programming language, biggest twist. Sir, what is the meaning of precedence? Sir, precedence does not means which operation should be evaluated first. Sir, what are you talking? You told us that precedence means which one should be evaluated first. No, actually precedence, coming to and or, many of the students get confused. That is why I am telling you this. Precedence means, if I ask you 3 plus 4 into 6. See, for 4, this operand is associated with two operators, plus and multiply. Here comes the picture of precedence. Precedence says with which operator an operand should be associated with. Precedence says with which operator and operand should be associated with. Is that okay? Sir, if the not symbol is before Pankaj, then what? Devbrat, what are you asking? You are saying not of Pankaj. You are saying not of Pankaj. Devbrat is asking this doubt. That if situation is something like this, Devbrat, what I told you about printf. Devbrat, what I told you about printf. In double quotes, it will treat everything as textual data, whether it is operator, whether it is digit or anything else. If you ask me that what is the result of this, then Devbrat, how does that really matters? How does that really matters? Sir, first of all, this printf executed. This printf will print everything inside double quotes. So how many symbols are printed? 1, 2, 3, 4, 5, 6, 7. After printing, the value becomes 7. So the entire expression becomes 7 and printf Sharma. Now tell me whether the second printf evaluated or not. Of course. See, short circuit evaluation happens only when the first operand is 0. Now the value also depends upon printf. That is why the second printf will execute and it will print Sharma. Because it printed 6 character, the value becomes 6. For AND operator, both of them are non-zero. That is why the result is 1. So later on 1 will be printed. So the result is not Pankaj Sharma 1. Is that okay? Is that okay? Devbrat. In case of any doubt, feel free to ask in the class. That is why live classes are there. Don't try to attend classes using recording. Just attend live classes. That's the beauty of live classes. Should I move further? Sir, precedence means with which operator an operand is associated with. Here, coming to 4 will say I will associate with multiply. That means can I parenthesize it like this? 4 into 6. Of course, sir. Sir, using precedence, I am sure that this 4 is associated with this multiply. Is that okay to everyone? Is that okay to everyone? Done, sir. Now, do I need anything else again? Do I need anything else to solve this question? To solve or evaluate this? No, sir. Now we know, because brackets, see, brackets is still bracket. The priority of bracket is more in C as well as in mathematics. So, sir, first of all, this will be evaluated and then the result is 27. Please try to understand that precedence does not really means which should be evaluated first. Precedence actually means if an operand is associated with two operators, with which operator it should go. Done to everyone? Done to everyone? Sayan, please don't ask the entire question, sir. What if we print like this? What if we print like this? Use your logic. I already discussed everything. What is logical OR? What is logical AND? Short circuit evaluation. It is completely waste of time, Sayan. If you keep on asking question like this, sir, what if the knot is here? What if the knot is here? I told you several examples. Just do it by yourself. In case you are facing some doubt, feel free to ask, but don't put an entire question. Don't throw an entire question on myself. Please. Done to everyone? So now, with this concept, let me try to give you few more examples. Let's see. Int a is equal to printf Tell me the result. Okay, one thing. Please tell me whether a window is visible to each and everyone or not. I am trying to open a window over here. Is this window visible to everyone? 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 Tell me, is this window visible to everyone or not? Visible to everyone, na? Is this window visible to everyone? Okay, sorry. See how silly mistakes I am. Sir, the result is Pankaj 1. Okay. Sir, how it is happening? Okay. Now tell me, sir, how the result is Pankaj 1? Because, sir, precedence does not say anything about which will be evaluated first. Otherwise, the answer should be Sharma, sir. Am I right or not? Arey, precedence says, see, this printf, for this printf, there are two options. Either associate with this or associate with this. Sir, the priority of logical AND is more. The priority of logical AND is more as compared to logical OR. That is why, sir, this printf must be associated with AND. So can I rewrite this? Like this? Okay. That means for this OR, this is the first operand. For this OR, this is the first operand, and this entire thing becomes the second operand. Okay, sir. Now, in order to get the answer of this OR, first operand will be evaluated. That is why this printf will print Pankaj. Once it print Pankaj, the value becomes 6 or this entire bracket. Now tell me whether this will be evaluated or not. No, sir, because short circuit evaluation says, arey, don't even look at second operand if the first operand is non-zero in case of logical OR. And that is why, what is the value that goes inside A? The value that goes inside A is 1. That is why the output is, tell me, if I try to print the value of A, the output would be 1. Is there any doubt regarding this? If not, then please solve the question. Int A is equal to I hope everyone must be enjoying. Is there anyone who think that doing questions is a waste of time? Arey, what is happening? I don't know. Tell me the result. Sometimes this screen irritates me. Anirudh is saying, but Sharma sir, one is also correct now. How it could be correct? I already compiled and executed the program, Anirudh. What ridiculous talk you are talking about, dear? Anirudh is saying, but Sharma sir, one is also correct now. How could be two answers for a question or for a program? Anirudh, are you out of your mind, dear? I explained everything. I executed the program. Still Anirudh is saying, but Sharma sir, one is also correct now. How could it be correct? Tell me the answer. Tell me the answer. Sir, as per the priority, this printf must be associated with this end. That means, can I rewrite the statement as, oh no, why this happens? Can I rewrite this statement as printf Pankaj and printf Sharma inside one parenthesis. Is that okay? And this OR is the second operand. This printf is the second operand for OR. Now, for this OR operator, this whole becomes the first operand. And this printf becomes the second operand. When you try to solve it, of course, first you will solve this. Now, because of this printf, Pankaj will be printed. And because of this Sharma, see, first of all, this will be printed. Of course, that is why. Let's try to understand the output. First, Pankaj will be printed because of this printf. But after printing, the value becomes 6. Now tell me whether printf Sharma execute or not. Of course, sir. There is no short circuit evaluation if the first operand of AND is non-zero. Sir, short circuit evaluation will not happen. That is why this Sharma, this printf also executed. And because of this, Sharma would be printed. Once this executed, the result would be 6 and 6 or printf sir. Now tell me, what is the result of 6 and 6? It is 1. because we have logical or operator, I'm writing over here PF, don't worry about it because I have less space. Now, because of short circuit evaluation, this will not be evaluated, and that is why 1 goes inside A and later on 1 would be printed. So what is the output? The output is Pankaj Sharma 1. How many of you are correct regarding this question? How many of you are correct regarding this question? Tell me honestly. Tell me honestly. How many of you are correct regarding this question? Great, great. Okay, let's move on to next operator, that is called as modify operator. Most confusing topic. Zero awareness about this operator, modify operator. So the next operator is modify operator. So there are two kinds of modify operator. First one is called as increment operator, that increase the value of a variable by 1, and second one is called as decrement operator. Two plus sign, two minus sign. Okay, again this increment operator is divided into two parts. First one says whether it is pre-increment, second one says post increment. Decrement again of two types. We have pre-decrement and post decrement. How they looks like? See, pre means before, so the syntax is something like this: plus plus on some variable. Post says variable plus plus. Okay, pre-decrement says minus minus variable. Post decrement says variable minus minus. So let's try to understand. I hope this is okay. You can make notes. Okay, let's try to understand. Sir, over here I'm writing two programs. Let's try to understand. Void main, int a is equal to 5. I perform plus plus a, then I try to print okay. Over here I am having second program. Please always remember that hash include stdio.h is there. It will just waste my time, that's why I am excluding it. So here we are having two programs. First program we are having some pre-incrementation, second program we are having a post-incrementation. And if you ask me the output of both of them is same. The output of both of them is same, which is 6. The output of both of them is 6. Sir, if the output is same, then how they are different? That means, sir, are you saying something like this, that that increment operator increase the value of a variable by 1? Of course I am saying that. But in this case, the answer is same. That means pre-increment and post-increment, the answer is same. Let me take another example and then I will try to explain further. Sir, this is the correct example to demonstrate pre-increment and post-increment. See, it's all about expressions. It's all about expressions. Now let's try to understand. Sir, here we have pre-incrementation. So what does pre-incrementation says? It's all about expressions. Pre-increment says pre means before using increase the value. So pre-incrementation says increase the value of the variable. That means in first step it says first increase the value and then use it. If you are using it for an expression, then use it. That means the statement becomes b is equal to a. That means, sir, this is equivalent to a is equal to a plus 1 and b is equal to a. That means you can understand it as a collection of two statements. A is equal to a plus 1 and then b is equal to a. So what happened in first case? Sir, in first case, try to understand. In first case, first a is increased by 1. So initially a is having 5. This becomes 6. From 5 it becomes 6. And then the same updated value, is assigned to b. So in this case, the result is 6, 6. But here, because we are having a post increment, what is the meaning of post? After. So it says increase the value after using it. That means first it says use the value of the variable. That means, and then increase the value. So in this case, this expression is equivalent to first use it and then increase the value of a variable by 1. That's it. So in this case, sir, what is going on? In this case, what is going on? Sir, first we use the value. That means because a is 5, the same 5 is assigned to b, and later after using, sir, a is increased. That is why the result of this code is 6, 5. Is that okay to everyone? 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 I'm not able to see your chat. Is that okay to everyone? Please reply fast. Is that okay to everyone? If someone is having my personal Telegram contact, please reply whether everything is going well or not. अंश भैया जरा देखना यार, ये चैट विंडो काम नहीं कर रही क्या? Now the biggest confusion, this is the hottest topic, this is hottest topic among first year and second year students. They keep on asking questions like this. They keep on asking questions like this. On the very first day, I am closing all this. They keep on asking questions like this just to impress others. Just to impress others. If someone asks you such a question, see, try to understand. Everything, you Nitish Kumar, what happened? What happened, you Nitish Kumar? Nitish? What happened? I am telling you a simple statement. consider pre-increment in 2-step as well as post-increment in 2-step. Consider pre-increment in 2-step as well as post-increment in 2-step. That's it. In previous question, plus plus a or a plus plus is not making any difference because you are not using it in any expression. You are not using it in any expression. Nitish, keep on asking questions. On every topic you keep on asking question. Sir, here, are we using it somewhere else? No, sir. Even if you wanted to understand this, because it is pre-increment, compiler will say a is equal to a plus 1. So the value becomes 6 and then use it. So the expression is something like this. How does that matter? A is equal to a plus 1 then 6. A is increased to 6. Of course, sir. Coming to here, a is having a value 5. Now this expression says first use the value. I am writing over here 5 and then increase the value. So because of this statement, this becomes 6. So what is the final value? The final value is 6. That is why in this case, the result is same. Because the value being used is not printed somewhere else, is not used inside a expression. Hope this must be clear to each and everyone. There are few students that keep on asking question, but still I hope, Nitish, this concept is clear to you or not? Nitish, this concept is clear to you or not? Nitish, this concept is clear to you or not? Clear? Clear? Everyone, is it clear? Now, we are over here. Sir, we keep on asking questions like this. See, there are some rules. Everyone has to follow those rules. So C standards, what does C standard says? C standard says there is a concept of sequence point. If you want to understand it, please Google it. There is a concept of sequence point. What is a sequence point? The sequence point is semicolon. There are many things which behaves like sequence point, but one such sequence point is semicolon. And C standard says that you can modify the value of a variable. You can modify the value of a variable at most one time. Between two sequence points, between two successive sequence point. So always try to answer question with some facts. Try to see. Many of you are even giving answer. I am telling you, this is a very bad practice. Just watch the question, answer. Hey, you don't know anything. Sir, between two sequence point, we are trying to modify the value of a variable 3 times. That is why the result is not defined. The result is not defined by C standard. If someone asks you in interview, tell him or tell her like this, sir, this concept is related to sequence point. C standard says that between any two sequence point, you are not allowed to change the value of a variable more than one time. Here, because we are trying to modify the value of variable a 3 times, as per standard, the result is not defined, and the result depends upon implementation. The result vary from compiler to compiler. That is why this is the most famous topic among students. 99% of students keep on learning about these topics. Still no result. Either they mug up things or keep on learning. But if standard says that the result is not defined, how can you predict the result? The result on Turbo C may be different. The result on GCC may be different. That's why don't mug up these things. If you want to stick to one compiler and learn the concept over there. So next time if someone asks this question, your very first answer is result is not defined. It may vary from compiler to compiler. So the next answer you can give is this result is compiler dependent. For placement purpose, either you can stick to code blocks. Am I visible? Am I audible? Are you getting everything? Is there any doubt regarding this? No, sir. Is it okay to everyone? Is it okay to everyone? Is it okay to everyone? Modify operator. Okay. Please reply. I am not able to view your comments. Please reply whether this is okay to everyone or not. Whether this is okay to everyone or not. Please reply whether this is okay to everyone or not. Please reply. Anyone who is having my personal Telegram contact, please tell me whether everything is going in correct direction or not, whether everything is okay or not. Is this okay to everyone? Is this okay to everyone? Is this okay to everyone? Should I move further? Is it okay? Can someone please reply? Anirudh, can you reply? Is it okay? Is it okay or not? Okay, let's move further. Now, sir, the next operators are bitwise operator. The next operators are bitwise operators. Sir, we know bits. Bit means sir binary values. We are considering binary values. We already know. If I ask you this, while solving this, did we converted 12 into its binary equivalent, or did we convert 3 into its binary equivalent? No, sir. While evaluating this, we are considering this 12 as a whole. We are not working on bits. But now what does bitwise operator says? In order to get the answer of bitwise operators, you need to work on the binary equivalent of the operands. So there are 6 bitwise operators. There are 6 bitwise operator. The first one is bitwise AND. And the symbol is okay. The second one is bitwise OR. The third one is bitwise XOR. Caret symbol. Fourth one is bitwise left shift. Bitwise left shift. Fifth one is bitwise right shift. And the last one is bitwise NOT or complementation. This is a tilde sign. This is a tilde sign. This is a tilde sign. Okay. Done. Let's understand first one, bitwise AND. Let's understand bitwise AND. First, if I'll say I am having int a is equal to 5, b is equal to 12, comma c. C is equal to a bitwise ANDing with b. Sir, ANDing can be performed between two values only. That is why can I say that these 5 are binary operators and this one is a unary operator. Okay, sir. Now, sir, first In order to answer this question, first I need to find the binary of 5. Do you know how to find the binary of a number? Do you know how to find the binary of a number? No, sir. If someone knows, still, I'm assuming that no one knows the binary number system. So let's first understand binary number system. Sir, there are many number system. The very first number system is decimal number system, which we know, which we use in real life. Decimal number system, a system in which there are 10 symbols. Deci means 10. Deci means 10. Anirudh, we will talk about Java later on. There are many things you can explore by yourself also. Decimal number system, that is 10 symbols, and those symbols are from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. See the problem. Okay, sir. We know about decimal number system, okay, that we used in real life, okay. There is another number system that is called as binary number system. Bi means 2. That means a number system that uses only 2 symbols, 0 and 1. That uses only 2 symbols, and those symbols are 0 and 1. Okay, sir. There are other number system also, although I will not discuss them right now because you will learn them in digital logic. Sir, octal number system containing 8 symbols. Octa means 8, starting from 0. How many symbols are they? So they are 8 symbols. Similarly, we have hexadecimal number system. We have hexadecimal. See, hexa means 6 and deci means 10. So overall 16 symbols are used in hexadecimal number system. How many symbols? 16 symbols. Sir, but there are only 10 digits from 0 to 9. So 6 are A, B, C, D, E, F. We will talk about it later. Okay, let's discuss one by one. Sir, do we know decimal number system? Do all of you know decimal number system, or should I need to tell you something? Sir, decimal number system. Okay, if I ask you what is the value of this number, you will say 3. If I ask you what is the value of this number, you will say 3. Of course it is 3. Okay. If I ask you the value of this number, you will say 34. How 34? Actually, this 4 is at unit place and this 1 is at ones place. How we used to find the value in 5th standard? Sir, face value multiplied by place value. Face value multiplied by place value. Face value multiplied by place value. That's how it is 30 and 4. Am I right? That's how it is 30 and 4. Of course, sir. Try to understand. Sir, its value is 34. If I append a symbol, over here, sir, now what is the value? See, previously 4 was at unit place, but because of this new symbol, 4 gets shifted by 1 position. That means from unit place it go at 1's place. Previously 3 was at 10's place. Because of this new symbol, it also gets shifted to 100 place. And the new symbol is at unit place. So if I ask you what is the value of this, so you will say 3 into 10 raised to the power 2 plus 4 into 10 raised to the power 1 plus whatever be the new symbol. See, the new symbol is at unit place. Okay, sir. Please look at the board. Previously, the contribution of 3 was 30, but now the contribution of 3 is 300. 10 times more it is contributing because it gets shifted by one position. Previously, the contribution of 4 is only 4, but now the contribution of 4 is 40, 10 times. Okay. Can I rewrite this like this? 3 into 10 raised to the power 1 plus 4 into 10 raised to the power 0, multiply this whole by 10 plus 5. If I am not wrong, this is the old value of the number. Can I say if I am having any number, and if I append any new symbol, then its new value becomes the old value, multiply the old value by 10 plus add the new symbol. Can I say this concept or not? It's very easy concept. If previously it is 34, if I append 5, it becomes 34 into 10 plus 5. Of course, sir. Is it okay to everyone? This concept is utmost important. Although many students don't use this concept. Sir, why 10? Because we are working in decimal number system. Okay, sir. Now, coming to binary number system. Sir, there are only two symbols which are 0 and 1. That means, sir, from childhood, we only know one number system, that is decimal number system. Now you are trying, sir, to explain a new number system called as binary number system. Then, sir, we must learn two things. Given a decimal number, how to convert this decimal number into binary number. Okay. And given a binary number, how to convert that binary number into decimal. Okay. Let's learn them one by one. So first, let us try to learn how to convert a given decimal number into binary number system. Let's try to understand. Let us suppose I need to convert 24. In decimal number system. Why 10? Decimal, 10 symbols. Okay. To binary number system. Why I write 2? Because that represent binary number system. Sir, how to convert? See, in decimal, everything happens in terms of 10. 10 raised to the power 0, 10 to the power 2, something like that. In binary, if you wanted to convert any number into binary, we keep on dividing that number by 2. Try to understand. If I divide 24 by 2, sir, the quotient would be 12 and the remainder would be 0. If I am not wrong, this is the remainder and this is the quotient. Please reply whether everything is okay or not. Sir, keep on writing quotient over here and remainder over here. So when you divide 24 by 2, the quotient is 12 and the remainder is 0. Again we will divide this 12 by 2. So if I divide 12 by 2 6 times we got 12 and the remainder is 0. Sir, when you divide 12 by 2, you will get quotient as 6 and the remainder as 0. Okay. Again we will divide this 6 by 2. We know if you divide 6 by 2, the quotient would be 3 and the remainder would be 0. Again if I divide 3 by 2, see, when you divide 3 by 2, it goes one time and the remainder is 1. So the quotient is 1 as well as the remainder is 1. So let me write the quotient as 1 and the remainder as 1. Now this is important. When you divide 1 by 2, how many times it goes? We already know modulus operator. How modulus operator used to work. So sir, 0 times it is 0 and the remainder is 1. So what is the quotient? The quotient is 0. The quotient is 0 and the remainder is 1. Whenever the quotient becomes 0, you need to stop the process. Whenever the quotient becomes 0, you need to stop this process. Is that okay to everyone? Sir, whenever the quotient becomes 0, stop the process. Sir, did we find the binary? Yes. Just write the remainder in reverse order. That means the binary is 11000. The binary equivalent for 24 is 11000. Get it or not? Get it or not? Get it or not? Okay, let's take another example. Let's take another example and solve it. Sir, let's try to find the binary for 67. Sir, if I divide 67, the quotient would be 33 and the remainder would be 1. If I divide 33 by 2, the quotient would be 16, remainder would be 1. If I divide 16 by 2, the quotient would be 8 and remainder would be 0. If I divide 8 by 2, the quotient would be 4 and the remainder is 0. If I divide 4 by 2, the quotient would be 2 and the remainder is 0. If I divide 2 by 2, the quotient would be 1 and the remainder is 0. Now, I hope the last step must be clear. If you divide 1 by 2, the quotient is 0 and the remainder is 1. When the quotient becomes 0, you need to stop. So did we find the binary? Did we find the binary? Yes, we find the binary. That means the binary for 67 is 1, 4, 0 and 1, 1. Done, sir. The problem nowadays with the students is they don't try to understand the foundational concept. What they want is to learn tough things. The problem is they don't even get to learn the tough things also, because if your foundation is strong, then only you can build a strong home over there. If the foundation is not strong, no matter how much strong the house is, it is going to collapse one day. And that's my TRP. Believe me, you have to trust me. Get the answer? How we are converting from decimal number system to binary. Now second is how to convert a binary into its equivalent decimal. How to convert a binary into its equivalent decimal. Let's take an example. Let us suppose I am having 11000. Is it in binary? Yes sir, it is in binary. Let's try to find the decimal equivalent. Sir, when a number is in binary, that means we are working in the powers of 2. We are working in the powers of 2. When a number is in decimal number system, we work in power of 10. But here, because the number is binary, what is the place value? 2 raised to the power 0. What is the place value? 2 raised to the power 1. Here 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4. Now how we try to find the value? Face value multiplied by place value. That is how 1 into 2 raised to the power 4 plus 1 into 2 raised to the power 3 plus 0 into 2 raised to the power 2 plus 0 into 2 raised to the power 1 plus 0 into 2 raised to the power 0. If I am not wrong, this turns out to be 16 plus 8 plus 0 plus 0 plus 0, which is nothing but 24. If you remember, you just find the binary for, what is the binary for 24? 11000. So if I convert this binary again to decimal, we will get 24. Done sir. 11000, the binary equivalent is 24. The binary equivalent is 24. Done sir. Let's take another example. 100011. Sir, again 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4, 2 raised to the power 5, 2 raised to the power 6. Okay sir. Let's try to find the decimal. So it is 1 into 2 raised to the power 6 plus 0 into 2 raised to the power 5 plus 0 into 2 raised to the power 4 plus 0 into 2 raised to the power 3, okay, plus 0 into 2 raised to the power 2, okay, plus 1 into 2 raised to the power 1 plus 1 into 2 raised to the power 0. See, 0 into something is 0. That is why the result is 64 plus 0 plus 0 plus 0 plus 0 plus 2 plus 1. So the result is 67. Previously, we converted 67 into its binary equivalent. Let's see. 14011. And now 14011, when I try to find the decimal value, I get 67. That means now we know how to convert a decimal to its binary. Now a beautiful concept. I wanted to tell you. Sir, it is written in binary. If I ask you what is the value? What is the value? It is written in binary. 10 in binary represent which number in decimal? In binary represent which number in decimal? Why only 2 replies? Only 2 students are replying. Why not rest of you are replying? Is everything okay? Okay, sir. The value is 2. Let me append a 0. If I append a 0, then the new value is, if you find, it would be 4. Okay, sir, what is the new concept? If you are having a binary number, whose value is x, if you append a 0, the new value becomes 2 into x plus 0. Sir, how? Previously we learned this concept. If you append a 0, if you append a new symbol, the new value becomes old value multiplied by 10. But previously we were in decimal number system. Now we are in binary number system. That is why it must be multiplied by 2 plus whatever be the new symbol. So if there is some binary number whose value is x, and if you append a 0, its value becomes 2x plus 0, or can I say the value becomes double? See, let's see, sir. Now the value is 4. If I append another 0, the value becomes 8. Please check whether it is 8 or not. Sir, if there is some binary number, if the value is x, if I append a 0 to the right side, then the value becomes 2 into x. Okay. Same concept, sir. If we are having a binary number whose value is x, and if you append a new symbol 1, then the value becomes 2 into old value plus the new symbol, that is 1. Let's see this also. What is the value? Sir, 2. If I append a 1, its new value becomes 2 into 2 plus 1. 2 times of old value plus 1. Can I say it is 5? Yes, sir, it is 5. Let's try to append another one. If I append another one, please check whether the value is 2 into 5 plus 1 or not. If I am not wrong, this is 11. If I am not wrong, this must be 11. If I am not wrong, this must be 11. So we get to learn one thing. So if now I ask you, find the decimal equivalent of this number. Sir, no worries at all. Sir, till here the value is 1. If I append a 0, the value becomes double. So double of 1 is 2. If I append a 1, the value becomes 2 times of 2, old value, double it plus 1. So 2 times of 2 plus 1, this becomes 5. Because there is a 0, the value becomes double. So from 5, it becomes 10. Because there is a 10, the value gets doubled plus 1. So 10 into 2 plus 1, it becomes 21. Now because there is a 0, from 21, it becomes 42. Now because there is a 1, the value must be 42 into 2 plus 1, so 85. Again, because we are having a 1, the value must be 85 into 2 plus 1, so 170 plus 1, it is 171. Now again we are having a 1, so the value must be 171 into 2, which is 342 plus 1. That is why the value becomes 343. Now we are having a value 0, so let me double 343 by 2. So that's why the answer is 686. You can cross verify. You can check whether it is 686 or not. Please check whether it is 686 or not. Please check whether it is 686 or not. Must be 686. Okay. Now we know binary number. Let's come back to bitwise operators. Sir, so the very first operator was bitwise ANDing. The very first operator is bitwise AND. Binary operator, if I am having int a is equal to 5, b is equal to 12, comma c, and if I write a bitwise AND with b, the very first thing, sir, convert everything into binary. So the binary equivalent of a, which is 5, is 101. But we know that integers either must be in 16 bit or 32 bits. So let me write it in 16 bits. So 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Similarly, if you try to find the binary equivalent of 12, you will get it as 1100, and remaining 12 zeros are there. 0, 0, 0, 0, 0, 0, 0, 0. Sir, why it is called as bitwise? Because now the ending of bits will be performed. The ending of this bit with this bit, the ending, the corresponding bits get AND. We are not considering the value as a whole. Now tell me, the logic is same. If I ask you 0 and 0, if both bits are 0, the result would be 0. If I am saying 0, one bit is 0 and one bit is 1, the result is 0. Of course, just like multiplication. So when the result of bitwise AND must be 1, sir, when both of them are 1, then only the result would be 1, just like logical operators. Here we are working on bits. So tell me the result. Let me do the ending. Sir, 1 is 0, that's why the ending is 0. 0, 0, 0. Both are 1, that is why 1. 0, 1, 0. See, here all zeros. Done, sir. That means this is the value, this is the binary value of C. So now if I ask you what is the value of C, convert this binary to its decimal, you will get 4. So what is the result? What is the result if you try to print the value of C? If you try to print the value of C, sir, if you try to print the value of C, the result is 4. So that's how bitwise operator used to work. That's how bitwise operator used to work. Sir, bitwise OR operator, same story. We need to convert the operand into their binary equivalent, no matter which bitwise operator you are talking about, except complementation, bitwise OR. So let me take an example. If I say int a is equal to 5, b is equal to 12, and we are having c, and if you write c is equal to a bitwise OR with b, I strongly recommend please try it by yourself first. First, we need to convert a and b into their binary equivalent. Sir, the binary of 5 is 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 1. The binary of 12 is 1, 1, 0, 0. Rest all zeros are there. See, there is no space, but I am inserting a space just for fast calculation so that counting is done. Now, what does OR means? Logical OR means if one of the operand is non-zero, the result is non-zero. That is 1. Similarly, if I ask you, if both the bits are 0, the result is 0. If at least one bit is 1, the result is 1. If at least one bit is 1, the result is 1. Okay, sir. So tell me, because coming to here, one bit is 1, that's why 1. Both bits are 0, 0, 1, 1. About these, sir, all of them becomes 0. All of them becomes 0. So the value of C is this. If you convert this into its decimal equivalent, I hope now you know the answer. Sir, 1, 3, 6 and 13. Till here 1, till here 3, then 6, then 13. Or you can calculate it like this way. 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3. So the result is 1 into 2 raised to the power 3 plus 1 into 2 raised to the power 2, 0 into 2 raised to the power 1 plus 1 into 2 raised to the power 0. So what is the result? 8 plus 4 plus 0 plus 1. The result is 13. So that's how bitwise OR operator used to work. Done, sir. How bitwise XOR used to work? Bitwise XOR operator. Sir, firstly, tell me what is the result if we XOR 2 bits. So, if both bits are same, the result is always 0. See here, both the bits are 0, that's why the result is 0. Here both bits are 1, that's why the result is 0. If they are different, the result is 1. If they are different, the result is 1. Different bits. Both bits are different, then the result is 1. If both bits are same, then the result of XOR is 0. That's how XOR used to work. Now let's see an example, simple example. Int a is equal to 5, b is equal to 12, comma c. Sir, if you perform a XOR b and try to print the result of c, sir, what is the result? Let's see. First, the binary equivalent of a, we know it is 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 1. The binary equivalent of b, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 1, 0, 0. Now we will perform the XORing. If we perform the XORing, because bits are different, we got a 1. Bits are same, we got a 0. Bits are same, we got a 0. Bits are different, we got a 1. For remaining bits, both the bits are 0. That is why the result is 0. So this is the value of C. So what is the decimal equivalent of this? 9. So the output is 9. So that's how bitwise XOR operator used to work. Please someone inform me at the Telegram that everything is okay or not. Please inform me at my Telegram whether everything is okay or not. I don't even know whether everything is okay or not. Okay. Let's talk about bitwise left shift. Bitwise left shift operator. Sir, again it is a binary operator. If I write something like this, that means we are saying saying left shift. Left shift, which one? 17. That means left shift the left operand. Left shift the first operand. See, this is the operator. This is the first operand. This is the second operand. So I am saying something like this, that left shift the first operand. How many times? 2 times. How many times? 2 times. If I ask you 19, so actually I am saying left shift 19 3 times. Sir, it is a binary operator. First operand we are shifting. Second operand, the number of time we want to shift the first operand. Left shift 19, left shift 19, how many times? 3 times. Because it is a bitwise operator, we need to consider the binary value. Okay. Let us suppose I am having A is 5 and I want to print the shifted value, left shift A by 1 time. Let's try to understand. Sir, what is the binary of 5? The binary of 5 is the binary of 5, or let me make it 10. Let me make it 10. Okay. Sir, the binary of 10 is 1 0 1 0 1 0 1 0, and now we have 1 2 3 4 0 0 0 0 0 1 2 3 4 5 6. Done. 16 4 4 4. Sorry, I hope they are 15 na. Now it's 16 4 4 4 4. Okay, this is the binary of 10 in 16 bits. Sir, try to understand. If I try to shift it left, if I push it towards the left, if I push all of them bits towards the left, what will happen? This bit will be popped out. This bit will be popped out. That means this bit used to come over here. This bit come at this position. This bit come at this position. and empty spaces created. And empty spaces created. Sir, this empty space is filled with a 0. This empty space is filled with a 0. So if I append a 0, tell me what is the new value? Of course it is 20. Of course it is 20. Sir, when you append a 0, the value becomes 2 times of the old value plus 0. So if I am not wrong, the answer is 20. But what if someone says printf %d left shift a 2 times? You cannot do it simultaneously 2 times. First you left shift it 1 time, then you left shift it another time. So now if I again left shift it one more time, what should I do? Okay, let's one, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. Again, once you try to push it towards the left, this bit will be popped out. This bit will be popped out. And this bit used to come over here. That means this is the 0 over here. This is the 0 over here. This is the 0 over here. Sir, 0 over here. 0 over here. We got a 0 over here. We got a 0 over here. 0 over here. We got a 0 over here. 0 over here. 1, 0, 1, 0, 0, and empty space is created. And empty space is to be filled with a 0. Now, tell me what is the new value? If I am not wrong, the value becomes 20. See, the initial value was 5. If you left shift it 1 time, it becomes 10. If you left shift it another time, it becomes 20. So every time left shift means you are multiplying the value by 2. So basically, if there is positive number, if I ask you 16 left shift 2 time, it is nothing but multiply 16 by 2 times. Or can I say 16 into 2 raised to the power 2? Of course, the answer would be 64. So that's how bitwise left shift used to work. That's how bitwise left shift used to work. Sir, how bitwise right shift used to work? Let's see how bitwise right shift used to work. Same. Bitwise right shift operator. Again binary operator. Again it is a binary operator. If you write something like this, that means we are saying right shift 17 1 time. Right shift 17 how many times? By 1 time. If I write something like this, that 19 right shift 2, basically we are saying right shift the value 19. Right shift the value 19 by 2 times. Right shift 19 by 2 times. Okay. Done, sir. Okay, let's see how bitwise used to work. Bitwise right shift used to work. So now if I say the value of A is 10, and if I ask you printf %d right shift A by 1 time, first print it and then print it. See, there is a difference between this and this. In this case, we are updating the value of A also, but in this case, the whole operation is performed at some temporary memory location. So there is a difference. Now, sir, first need to find the binary equivalent for 10. First, we need to find the binary equivalent of 10. So it is 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0 and 1, 0, 1, 0. Okay. Done, sir. Now, if I push all of them towards the right, this bit will be popped out. This bit will be popped out. And all other bits are shifted by 1 position. That means, I hope this is okay, or otherwise I will write it like this. Don't worry. Okay. Now, sir, this will be popped out. This used to come over here. This used to come over here, and this used to come over here. That is why we have 1, 0, 1. And coming, what about this bit? This bit used to come over here. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. Okay, sir. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0 and a 0. Again we have an empty space, and the empty space is filled with a 0. Now tell me, what is the value? 1, 0, 1. Sir, it becomes 5. That means, sir, is it so that the value is becoming half? Yes. If you right shift it one more time, this value will be popped out. This bit will be popped out. And the value becomes, try to understand, 0, 1. See, I am removing this and shifting all of them by 1 position. So 0, 1, 0, 0, 0. Try to understand. Please try to understand. This becomes 0, 1, 0, 0, 1, 0. Okay. And all of them are 0. And an empty space is created. The empty space is also filled with 0. Now if I ask you what is the value, it becomes 2. So what is the half of 10? Sir, the half of 10 is 5. What is the half of 5? Sir, both are integer, that's why the answer is 2. That means, just like left shift operator means multiplying a value by 2, right shift operator means dividing an value by 2. So if you ask me, what is the result of 10 right shift 2? It is as same as divide 10 by 2 raised to the power 2. So 10 divided by 4, because both of them are integer, the result is an integer which is 2. So that's how bitwise operators used to work. Tomorrow we will discuss the remaining operators, that is bitwise not and more assignment operator in details. So as of now, goodbye from my side. Take care. Good night.